Good afternoon. We resume our lecture on this series of lectures on Six Sigma, and the particular topic that I'll be covering today in this session here is called quality function deployment. It's a key approach to try to design new products or new services, and this is quite different from the way the products or services they were designed and offered in the marketplace conventionally. This is quite a radical departure. It takes you a lot closer to the user. It takes you a lot closer to the marketplace, to the actual place of use, and it lets you interact a lot with the user, the potential user, to try to make sure that his requirements are understood and they are met by the final product or the service that you're going to design. It does away with a lot of stuff that is bells and whistles on the product. You know, this is a pen, that's a writing medium. And really, I do not have the need to have a digital watch there, for example. There's just no need for such a thing. Perhaps if it's an ink pen, I do not want to have other kind of gadgets here. Those are just not required. At the same time, I want to make sure that requirements, for example, when I put it in my pocket, then the clip stays the way it's supposed to be. The pen doesn't fly off. Number one, the cap sticks, it shuts with a click, and also it produces an airtight seal so that the pen doesn't get dry when it's time for it to be just put away in storage, for example, and so on and so forth. What exactly is QFD? QFD is a new approach, and let's take a look at some of the differences between the conventional approach to design a product and doing it the QFD way. QFD stands for Quality Function Deployment, and we'll talk about this quite a lot in this session as we go along, and you'll really see how we are deploying the quality delivery capability of the organization in trying to make sure what we produce is a good fit in the marketplace in the hands of the user. How does QFD begin? The very first step in QFD is listen to the customer. Listen to the customer very carefully. It's very important for us to listen to the customer very carefully. This is very, very important. We've got to pick up every signal that is there. What exactly is he trying to convey to me? This is very, very important. And perhaps we'll be asking some special questions so that we catch those nuances, we catch those small things that he might mention only very casually, but they might be very important when it comes to choosing a product and not choosing another one, for example. So listening is very important, and this is when we try to also decide what is going to be important for the customer. Then we move down to the step when we develop and manufacture. What we really try to do is toward measured goals, and these goals are going to be set by having listened to the customer. If I've listened to the customer carefully, I've set some concrete, these are quantified goals about the design of the final product. This is what I've done by listening carefully. Then, of course, the last stage in the QFD approach is you optimize the product or the process. What are you trying to optimize there? Then you might worry about cost, you might worry about manufacturing methods, you might worry about making sure the quality is there, quality assurance methods and so on. All of those, they have to be thought through, they have to be walked through. If you've done that, you've done away with the fat, anything that is not needed, you've removed that, and your effort and your resources are going in exactly to fulfill what the customer requires. And then the place is going to be, the placement of the product is also going to be the best possible placement. What is the difference between that and the conventional approach? Let's look at the conventional approach to designing a product. You start with what we call specification. So if it's like a pen, what are the specifications of a pen? First of all, let's look at the two parts. We got the cap. The cap has a clip. And if you look a little closer, the clip has a little tolerance there. So some numbers will have to be given there. There's a length of that clip there. Then you come to the top of it, there is a certain curvature there that gives it perhaps some aesthetics. Then you look inside, there's a hole there, and the body has to go in there. And that fit has to be airtight so that the ink doesn't dry out when the cap is on. And also it should not be too loose so that it should not fall off, for example, when you're walking about. That also shouldn't happen. Then you come to the body of it. There is the size and the physical dimension. Then of course the actual writing media. In fact, the ink, the choice of the ink and the choice of the tip of the pen, all those things they have to be specified. In the conventional case, all these specs they were given equal importance. Everything had to be specified exactly the same way. There was no such thing that the clip is more important than the tip, or this tail is as important as the tip, and so on and so forth. In the conventional approach to designing products, all specs they were given equal importance. And who actually wrote those specs? Those are probably written by the draftsman in many cases, sometimes by the engineer, and at other times it's also possible that the worker, from his experience, he put down some tolerance there. That is there. So it was not determined systematically, it was not determined scientifically. And that is like one big difference between the conventional approach to designing a product and doing it the QFD way. Of course, then what we do is, once we got the specs there, then we design our manufacturing system. In the conventional approach, we would then say, well, now we have to come in. Perhaps for the cap, we'll be doing injection molding. And the specs are given there, therefore that is going to give us the size of the holes and everything else. When I design that little die that is going to be casting these little plastic caps, that will come about only after I've given the specs for this. Then of course I've got very passive reaction to customers. Okay, people come back and say that, look, your pen seems to be slipping off the cap. I won't worry too much about it. Also, a few pens do that. Really, again, what I'm doing is I never really listen to the customer, and I design things my own way. This is not a way, this is not a manner in which you would succeed in the marketplace. What are some of the uses of this new approach called QFD? In fact, it turns out that you become better to make demands on the process capabilities that you have, the quality deployment capabilities that you have, the quality delivery capabilities that you have in the company. Your demands become sharper, demands become more precise. You follow a systematic working method. In fact, it provides you a direction that's well thought out. That's what it does. When you're trying to develop a product using the QFD approach, your direction is set forth very clearly. You collect the appropriate knowledge. It's very important for us to realize that we collect the appropriate knowledge and we transfer the knowledge to the right person who is going to be using that knowledge to be able to do it. It might require some training, but we'll do that. We also do systematic evaluation of existing product. This is sometimes not done in conventional approaches. In fact, what we are trying to do here is learning from the mistakes and learning all these different ways by which the older products, they did not succeed in the marketplace. Why didn't people like the older products? We never bothered finding that out actually in the conventional way. Then of course, the problem is we have design changes that take place. But if I use the QFD approach, there are fewer design changes later on. Most of the changes take place early on in the design stage. Later on, of course, I do not have that problem there. The total development time of taking a product from concept all the way to the final, not only prototyping but field testing also. This total duration is reduced by 30, 40, 50% by the QFD approach. And the needs of the customer, they pick up the sharpest focus. And in fact, it turns out every activity that you then do in the design shop or trying to make sure your manufacturing system also is able to deliver what we are gearing up to do, the focus becomes really, really sharp. These are some of the uses for QFD, for using going the QFD route. What are some of the causes by which designs may fail? Not enough basic knowledge on hand. That's like one of the reasons. And read the other ones. Corporate management's view is very simplistic. If they think of a new product, they just think, well, we've done something like this before. What should be the problem in trying to do it again? Too little activity at the beginning of the project. This is also a big problem. It's very possible many times that we do not do enough homework before we begin the project. There may be unspecified demands and constraints, those also may be imposed, and that's why designs may fail. There may be non-existing specifications or there may be bad specifications. There may not be enough time to be thorough. This is very important, and I may actually turn out with I may launch a product without realistic time frames. I may go ahead and do that. And also, generally speaking, you do not have good cooperation between marketing people, the customer, the designers, the engineering people, and the manufacturing people. You do not have good cooperation between them. If you do not have that, your design is likely to fail. Let's look at a couple of profiles, and these are the profiles of utilization of the capability of the company, of the organization. There are various capabilities involved. For example, product development, that's a very major capability of a company. Preparation to move toward a new design and gear up your production facilities for that. Then do actual production. Then you do troubleshooting, problem solving, field service, and so on and so forth. These are various types of capabilities that the company has. In the conventional method, not much of the early part of this work is done. Not much of the early part of this work is done. In fact, most of it piles up being problem solving toward the end of the project. That's where most of the activity tends to pile up, and that turns out to be what is the activity that really picks up weight there? It is problem solving, because I've not done good work. I've not done enough work early on in the project. As opposed to this, what QFD does, it spends a lot of resources and time right early on in trying to develop the right design, understand specifications, perhaps do some prototyping, perhaps cross-check with customers, and so on and so forth. Prepare very well, make sure production people are in gear with whatever is coming along. And the result is this: there is hardly any problem-solving issues left. There are hardly any problem-solving issues left when you follow the QFD route. Again, if you look at a history, look into the history. In Japan, QFD actually started in the shipping industry. There's a town in Japan called Kobe. Some years back in the 80s, Kobe had a huge earthquake. That's how many people heard of Kobe. But Kobe has a huge shipyard, and they had to build these large ships. Their convention was that they'll produce almost a complete ship, then they'll bring in the buyers. So the ship was already standing in the shipyard. Then they'll bring in these buyers, and the buyers would take a look at them, and the buyers would probably say, "Well, I don't like the mast there. I don't like the that placement of the anchor there. I don't like certain things. Why don't you make those changes? Then I'll take a look at the ship again, and then perhaps I'll make a bid. I'll probably say how much I want to pay for it." This ended up with a lot of changes that had to be made on that almost complete ship. This is very costly, because the customers won't pay for all these things. They'll just say, "This is what we want. If you want to sell it to me, give me the product the way I want it." The difference between that and the new way of designing a ship that came by the QFD way was involve the customer early on, making sure, and we'll be doing that with a couple of examples. We'll be doing that. I'll show you exactly what is going to happen. You involve the customer early on. That is like your launch date. For example, the ship might take a couple of years to build. About 2 years before that, as soon as the concept starts kicking off, you involve the customer and you start your activity right early on. So you put in a lot of work right at the beginning. And then the other work they follow, they become much smoother. So in fact, if you look at the profile, look at the resource requirements and the profile of the two approaches to design a ship. In the conventional wisdom, a lot of work is done toward the end of the project. In QFD, a lot of work is done at the front end of the project. That's when you're trying to hammer out concepts and so on and so forth. And I'll show you exactly what is done at that stage of the thing. They slowly start getting into what we call the cost of arriving late to the marketplace. Suppose there are delays. Suppose there are problems like this, and the result is this is going to be causing some delays in reaching the marketplace. Look, some of the activities are continuing, and they're going beyond the deadline. This was the committed deadline for shipping the product. and I'm still continuing to work with it. Perhaps certain things the customer does not like, or certain things do not work, or the specs are wrong or something, and I keep continuing to work on this. When I do this, the problem is I'm late in reaching the marketplace. If I'm late by 6 months in shipbuilding, my profit goes down by 33%. If I'm late by 5 months, 1/4 of the profit is gone, and so on and so forth. Even if I'm 1 month late, there is some profit lost. Why should these be there? Why should these losses be there? Can something be done about it? Yes, if you change the convention, if you walk away from the conventional practice and you go toward the QFD way, a lot of these costs would just disappear. Let's see how that happens. QFD puts a task in a chain. Every task is actually put in a chain. For example, when you do product planning, you're interacting with the customers and you're determining customer requirements. From that, you'll come up with hard numbers, the design requirements. So I find out customer requirements. From that, I determine my hardware requirements, these numbers. Then I go into details of my product design and I come up with requirements for the parts and the items and the materials and so on. So I start with my design requirement, and my product design will end up specifying the parts and the item characteristics. That's what happened there. Then I do process planning. I have to produce this product, so I go into process planning. How am I going to be producing this final product? Well, those would start with the parts or the items that I need and the process operations that must be there. The features of the process operations must ensure that I'm able to deliver these characteristics. And of course, once I've got my process operations specified, I go into process control. I say, how am I going to be controlling that process? And I specify the operations requirements. So what have I done? I started with customer requirements. From there, I determined my design requirements. And you'll see how I do that. Then I spell out the parts and items that I require. Then I'll come up with process operations. These are the process requirements that I have in order for me to produce those parts and items. Then of course I've got some operational control issues that I have to settle after I've specified what are the different processes that are going to be there. So what is QFD? It's actually an optimization method. It goes from product concept all the way to production. So you start with the product concept and you rise gradually to the level of doing actual production. And you do it very systematically. Let's see how we do it. We will start with QFD, recognizing that QFD is a tool, and QFD is actually a quality tool. What is a quality tool? It is something that's going to raise the level of satisfaction that the customer is going to have with my product. That's going to be the role of QFD. That's going to be the character of QFD. It captures the voice of the customer. This is perhaps the most important thing that QFD does. How does it do it? The customer may express his wishes around a product or the activity. He may just say, I wish I had a product that did like this. Like for example, we could do QFD even for a pen, for example. And the customer would probably say, I want something that I can hold in my hand that should be able to write. It should produce, a scratch or a mark that is almost like it has come out of a regular pen. And it should not dry out very well. It should close very well. It should be portable. It should be sleek, and so on and so forth. So the customer will come up with her own requirements. I do that. Then what we do, we get the design group together. We say, well, here's a customer. She has spelled out these requirements. She has spelled out these different requirements. And having spelled those out, I now have an idea of what she requires. Now let the creative people, the designers, get together and see how am I going to deliver those requirements. I have to eventually produce something that's going to be a tangible hardware or perhaps a piece of service. I start with the requirements and I slowly convert those into this product. This part is creative. This part is when the designer team is involved and they do a lot of creative thinking to try to see how I can take something that's as vague as some wishes. And I eventually have to come up with specifications that are hard, that are like tangible, hard, codes and numbers and so on and so forth. These are going to be the starting point for me to do my actual physical design work. So the design group will then basically identify these things, and they will come up with specifications, they'll come up with details and so on and so forth. I'm going to give you an example how this is done. This total task, by the way, the total task of QFD is organized in a worksheet, and the worksheet looks like a house as I show here. What does this house comprise? It's got a wall here, which is what the different requirements as spelled out by the customers, those are put out. So the requirements, customer requirements are put out here. Then the engineering team gets together and they try to look at these and they try to say, well, to try to take care of those requirements, I have to do A, B, C, D. These are the various things I have to do to make them as part of the product. Only then I'll be able to take care of these requirements. So these are the how I'm going to meet those requirements. And these ideas have come from the design team. Now, why am I doing all this? Well, partly because there is competition, and partly because I'm going to be reaching a high level of satisfaction. The final product will have a high level of satisfaction. That's why I'm doing this. The hows are then converted to how much. Now, these are quantified numbers for each of these requirements. Now, these are customer requirements and these are going to be design specs. And design specs actually, they end up being numbers. And of course, up here you've got a correlation matrix there, also you've got a correlation matrix there. These become a little more clear when I go to the next slide. This is the next slide. And let's say I'm trying to design a service facility that will produce dry clothes. It's a dry cleaning operation that I want to set up. There already are 2-3 other guys who are in this business in the same area. It could be the IIT campus, for example. Somebody wants to set up a dry cleaning shop. What he does a survey of people. What are the different things customer require? And this is the left wall of that house there. And customer survey reveals that people want their shirts to be completely clean. They want the press to be complete, perfect press. They do not want delays at the counter. They want quick turnaround service. They want friendly service. These are some of the requirements that customers have pulled out. And when I talk to the customers a little bit more, they say, as far as I'm concerned, clean clothes are priority number 1. Perfect press is priority number 2. Quick turnaround is priority number 3. Friendly service is 4. And no delays at the counter is 5 in order of the priorities. These are now customer requirements, and I've got the importance to the customer also pulled out here. This has come by talking to the customers. This is exactly what the voice of the customer is. Then I get my design team together. These are the people who are knowledgeable about the operation of a dry cleaning shop. They have worked in similar areas. They have probably run some shops. They have probably run some machines that do dry cleaning, for example, and so on and so forth. So they come up with, they say, well, to be able to deliver these things, we require good training. We require good dry cleaning fluid. We require good filters on the in the system. There should be no rust in the different solvent lines. The press pads should be firm, and of course, equipment maintenance must be also top notch. If you do these things, you are going to be able to take care of these requirements. So notice here, this did not come from the customer. The customer just gave me these, and these came from my own people. That is the expert, they are operators, they are designers and so on. They are familiar with the dry cleaning business. They are the ones who say, if I have these things, we should be able to do that. Then of course, we got some important weighings there, and that will come along. And we quantify some of these things. For example, how much training should be there? The team decides that a good practice would be 4 hours of formal training, 4 hours of formal training, and 2 weeks of on-the-job training should really get someone ready to be able to take charge in the shop there. The cleanliness of the solvent should be checked visually and daily. And again, cleaning of the filter itself, that also could be checked daily in this thing. And of course, we've got no rust in the pan, that also has to be checked visually. As far as the presses are concerned, those pads could be changed monthly. And of course, good equipment, perhaps there should be a maintenance schedule, a monthly maintenance schedule that will take care of that. Then what we do is we look at competition. This is the why. Why is it that we have to design a super duper dry cleaner shop? The first thing is we got to succeed. We want to succeed in this business in the marketplace. That's why he's putting all this effort about understanding what the customer requires. And I got my team together to find out how I'm going to take care of those requirements there. These are the whats and these are the hows. And on this side now, I do a comparison. I look at my competition. There are two competition. There is one competition A and competition B. And I rank on a scale of 1 to 5. I rank on a scale of 1 to 5. 5 is the best, 1 is the worst. Where are A and B in regard to meeting this requirement there? And for this, I may have to do some spying, or I may have to actually produce some clothes, give them some dirty clothes, and see how clean those shirts come out, how good is their press, and so on. And I do that, and I kind of rank A and B, both businesses, on the scale of 1 to 5. Having done that, I also try to sort of find out, I've got to set my own target. I've got a profile now for A, and also I've got a profile for B. It turns out that I want to design my new shop in such a way is better than both A and B. Also, I want to design my shop in a way that is going to be better than A and B again. But A and B are at level 1 and 2. I need not go beyond 3. As far as this factor is concerned, no delays at the counter. I'm providing a lot of good service, so there is really no need for me to try to overtake A and B. I could just be there, and that will be probably good enough for me. I can change that later on, but at least initially, it will be good enough for me to do that. Friendly service, well, my service is probably not going to be terribly friendly because the other guys, they don't do a good job in dry cleaning, but they have very friendly people there. I'll just start out with the people that we have right now. Then we'll worry about the receptionist and everything else. And as far as friendly service is concerned, we want to be slightly better than the other ones. So I set these as my own targets. Then of course I set my technical targets also. So here in the final specs of things, the ones that are marked X, those are going to be my requirements. And what I've ended up with, I've ended up with the specs of a new dry cleaning business. And I've done this very carefully. I've started with customer requirements. Then I found out, what the means would be to try to take care of those requirements. Then I looked at competition. I tried to find out how well they were meeting these customer requirements that I just found. Then I decided, based on the profile of my competition, as to how I'm going to set my own target, the specs for launching my own dry cleaning business. I do that. This is now much more systematic than just saying go into a business and set up the shop like anybody else. We are doing it much more precisely. Just an overview of QFD. The history is it started with shipbuilding in the Kobe area, and it was adopted then later on by many Western companies, almost every Western companies, and certainly automotive companies, they are using this. And it turns out QFD is now an important step in I in the DMAC procedure of Six Sigma. Some of these questions are still probably there. What is QFD? QFD is a way to convert customers' voice into product specs. Why use QFD? You'll end up with a better fit and reduce a lot of wasted work. And what are the characteristics? Number one, it's very systematic. Number two, it involves people. Number three, gets commitments all the way across. And people find out exactly, very clearly, they find out what is going to be their role in making sure that the customer has the highest satisfaction and the company's resources, they are deployed in the best manner possible. And of course, I've got some more slides here that give you some more background, and you can review them the way you want. I want to really move up to something that is going to be another aspect of talking to the customer. And that's going to be done by going away from the voice of the customer to the mind of the customer. And let's see how we do that. As you go into the design of the product itself, You have various requirements that have been spelled out, completely clean, perfect press, and so on and so forth. Are all these requirements equally attractive to the customer? Now, this was something that we didn't do when we asked the customers. We just asked them what you consider to be important. That's all. But we didn't really get into his mind. And that is done by this new approach called the Carnot Model of probing a little deeper into customer satisfaction. Let me show you how that is done. And I'm going to be doing that by going to, I'm just flipping through the slides which are basically informative only. And I'm going to be going to this Carnot model slowly, and that's going to take you to the point when you will know that it's important for me not only to know what the customer requirements are, but what do they do for them. This approach, this new Carnot approach, was created by Professor Noriaki Kano, also from Japan. Like QFD that came from Japan, the Carnot model has also come from Japan. What exactly is done here? It helps us understand the perception of quality in the mind of the customer. How does he or she view a particular quality characteristic? What is her perception? And I've not said much about this yet, but let me just do that by going right to the bottom, which says there are certain quality characteristics that are basic requirements. These are the must-have, and I'm going to give you some examples here. So as far as dry cleaning goes, obviously clean clothes are a must. Firm press also is a must. This is something I cannot do without. Perhaps these are functional. Perhaps the must is a good price only. It must be of good price. But as far as functional characteristics go, as far as performances go, perhaps it is clean clothes and perhaps it is firm press. These are going to be there. So I've got a must there. The must requirement is at least it should not cost me more than what it cost me in the marketplace. That's my dry cleaning service. But as far as functionality is concerned, and these are attributes, the more the better. So the cleaner is the cloth, cleaner is my shirt, the better it is. The firmer is the press, the better it is. That's a functional characteristic. Then there are other types of characteristics which delight the customer. It could be, for example, friendly service. It could be a reminder that your shirts are ready, for example. Perhaps an SMS. If I send an SMS on his cell phone, sir or ma'am, your clothes are ready. You can pick them up anytime. That's going to be a delighting factor. So let's go back again and let's try to find out how Carnot changes from QFD, how the Carnot approach changes from QFD. In QFD, basically, you've pulled out all the requirements and you've done that with very careful study of customer requirements. Once you've done that, you have a pretty decent idea to be able to go into this business. I know my customers, my competition, my competitors, they are also offering some of these similar services. I've got to make sure I provide better service than them, for example. But perhaps there are parts of it that are viewed differently by customers. Different in the sense, having clean clothes and getting an SMS that my clothing are ready. These are needs, all right, but one is sort of like a functional requirement. If I'm given for cleaning, it's got to come back clean. It's got to have good press. That's a functional requirement. The price has to be right. That's a basic requirement. If the price is not so good, I'm going to be dissatisfied. As far as the functional requirement is concerned, the more the better. But then there's this SMS is a surprise factor, a complete surprise factor. That's something that delights you. You'll feel like doing more business with him. This is exactly what is brought out by the Carnot model. This was not there in the old QFD, but by converting it to a Carnot sort of framework, I'm now distinguishing between different types of needs that have been spelled out by the customer. Now we are saying certain things are basic. I cannot really take chances with them because that is the price for entering this business. I've got to make sure the price is right. Otherwise, he's not going to come to me, number one. Number two, to keep him there and to make sure that my prime business continues, I've got to provide the basic service, not the basic, now the functional services, the way it should be. And for that, again, I went back to the different requirements and I found out and I figured out, and this might require some interaction with the customer, that firm press and clean close, these are something that is right, the more the better. So these become functional requirements, different from the basic requirement, which was only price. Now these are functional requirements. Then is the third factor. Suppose these two are there, these two are already there. What would make you to go back to a particular dry cleaner and not to another one? Perhaps the guy who sends you that SMS, sir, your shirts are ready. That's going to be a delighting factor. So this way we have gone beyond. We have gone beyond basically just hearing the voice of the customer. Now we have probed into his mind and tried to find out, what really are his basic requirements that really would get me into this business, for example. Then what are the things that he expects more of? And perhaps he can even pay a bit more because of this. And those are the functional requirements. And what are those extra things that basically delight him? They are the surprises. And they are the ones that we look out for whenever we have a purchasing experience, for example, we do that. So basically what we're talking about is the Carnot model captures the mind of the customer. The basic requirements must be met. There is no escape from this. The performance requirements, the more the better. The cleaner the shirt or the firmer the press, the better for us. We feel better. Then these delighters. Just like that SMS that arrives as soon as my shirt is ready. It's like a worry that has gone off my this thing. Because I'm returning from the office. Time is 6 p.m. And I don't want to make a call to that person there. It would be nice if I could collect the shirts today. It would be really nice. As I walk by his store, it's just a, probably stopping for 2 minutes and picking up my packet. That's it. That's all it is. And I'd really like to do it, but I don't want to make this phone call because I'm too busy anyhow. Who bothers about making a call to his dry cleaner, for example? But lo and behold, at 3:30 I get a SMS. And it says, sir, your shirts are ready. That's a delight. That's an absolute delight. My God, these guys, they really think of us. They really think of customers. That's going to be that delight. This is the extra. And this is always there. Let's take a look at some of the pictures, pictorial view of this Carnot model there. There are two axes. There are two axes there. There is a horizontal axis that basically talks about the functional characteristic of the product. On this side, the midpoint is the neutral point. Midpoint is just the beginning, is the neutral point there. As you move toward the right, the product does a better and better job. As you move to the left, the product does a worse and worse type of job, and down below here the product does not work at all. No clean shirts in this area. And here you've got medium cleanliness, and over here you've got better cleanliness. With that, there's something that we call performance needs of going to a dry cleaner. Those rise as you move toward this side. Those rise. The more the better. Those are performance needs. These are articulated, these are specified, these are measurable, these can be found by talking to the customer. And these are useful in comparative analysis and interviews. In fact, the old QFD basically focused on this only, the old QFD. And this is what comes out in the voice of the customer. But if you start probing into the mind of the customer, you discover two other aspects. One is these needs, these are called the basic needs. And the basic needs are such, if they are not there, if they are not delivered, dissatisfaction is high. So in this lower part, dissatisfaction is high. But you really don't get delighted if your basic needs are met. You just rise to a certain level of plateau and you stay there. It does not really become all that more better. For example, price could be, price, everybody realizes that to get a shirt clean, for example, it might cost 10 rupees, as an example. In certain cities, it will cost you 10 rupees in a store. And that's kind of a basic price. You don't want to offer 4 rupees or 2 rupees or 3 rupees because you'll get a trash job then. So comparable services, they are offered at 10 rupees. So that's like your basic need. You don't want that price to be high. If it's like 20, 30, 40 rupees, obviously it's going to be hurting your basic need. Your basic need is make the cleaning business affordable. Make the dry cleaning of my shirt affordable. That's like basic needs. So the basic needs, beyond a point, the dissatisfaction disappears, but you don't really get delighted or something like that. It kind of levels up at this point. Then these other factors. These factors are of a different category. They're different from the basic needs. They're also different from performance needs. These are the excitement needs. We want to be thrilled once in a while. We want to be thrilled, and that would come like that SMS that comes to you at 3 p.m. That your shirt is ready. That would come along this way. And here, of course, the more the better. In fact, if there's a lot more of it, it delights us even more. And these are, of course, these generally have an element of surprise also. So in fact, to win in the marketplace, you got to make sure you're at this end of basic needs, you're near at this end of performance needs, and you provide some element of surprise, some element of what we call delight. Now that was the basic Carnot model. Professor Carnot also came along and he said, this may be the picture today, but given some time, what we consider to be completely basic need, things change with time. For example, something that delights you today may not really delight you tomorrow. It may become a basic need. For example, let me give you a couple of examples. One example is, cell phones with cameras. Initially, they were just plain cell phones. And cell phones themselves were delighters if somebody had a cell phone. I remember 10 years ago, a couple of friends of mine who had cell phones, they could call up people in New York and anywhere else. So if they are out in a party or they were in a park somewhere or they were they were having a particularly good time, they wanted to call up their near and dear ones. And lo and behold, they could just go on their cell phone and make a call. That's a piece of delight. Gradually, as time went by, some 2, 3, 4 years of using that cell phone, those became basically your functional requirements. They became a functional requirement, so they met a particular need in a pretty nice way. They gave you portability, and that also was one of the functional requirements of telephone, which the landline did not meet. Therefore, what was delighting at one point in time, which was just having a cell phone, those became what we call a functional requirement. As time went further on, and I'll say probably today, if you look at even 3, 4, 5 years ago, past 4, 5 years, we take the cell phone to be something for granted. It's a basic need. You cannot leave your home without a pen or your car keys or with a cell phone. It's a very basic need. If it is not there, you're dissatisfied. If the cell phone is not there, dissatisfied. So what has happened? With time, something that delighted you once became a functional requirement, and it has now become just a basic requirement. The same thing for the camera on a cell phone. Initially, when a camera was built in, these cameras were very poor cameras. They're nothing like the digital cameras. Some 128 kilobytes and so on, so they took very smudgy, very poor pictures. You could barely see the profile. Even newspaper prints were better than the picture that you took with a cell phone camera. But they gave you something extra. So some kids who had the camera with a cell phone, they obviously delighted. Other people wanted to be that way. So this was a factor that was delightful. Then these capabilities started to improve, and today it has become functional. And I'm pretty sure the time is not that far when we'll consider it, we'll take it for granted that, my God, if I get a cell phone, it's got to have what we call a cell phone. It's got to have a little camera built in there. Now, something that is not there probably in not many telephones is a recording device. So if I do have a conversation that I wish to tape, perhaps there could be a button there. and I could tape my conversation. This would be a delighting factor today. As time goes by, those would gradually become functional, then those might become basic needs. Now, going back again, with the Carnot model, we've got the basic requirements, and these have to be found out by interacting with the customer. And basic requirements are such, these are the price of entering that business. This is the cost or price of my entering that business. I got to take care of these. If these features are not there in the final product or the final service, the customer is going to be dissatisfied. A lot of examples are there for this sort of thing. Then we've got performance attributes. Performance attributes are those things where the more the better. Customer satisfaction rises as I provide more and more of these performance attributes. Then of course what we have is the exciting factors. These are the ones which are, these generally come in with a pinch of surprise, and these offer the unexpected, and these really offer sometimes great satisfaction. And in the case of the dry cleaning service, for example, we realize the price that the store is offering, that's basically a basic requirement. Function characteristic, which basically gets into your, the cleaner the better, or the firmer the press the better, and so on. So that's a function requirement that is there. Then of course we got the delight factor, and the delight factor, this would require some ingenuity. Now you're really trying to work with the upper levels of the mind there. You're not looking at just the basic physical requirements. In fact, the older QFD focused mostly on functional requirements. It took the basic for granted. It took the basic requirements, the basic needs for granted. It did want to make sure it did not leave out any of the basic requirements. But it did focus a lot on meeting the functional requirements. And it did everything like we did for the case when we were trying to design the dry cleaning shop. We looked at cleaning fluid, blah, blah, these things. Those are all functional requirements. We did not put in the SMS requirement there. It was not even thought of. It was not even mentioned by the customer. But that's what we thought of when we thought a little hard. We said, there are these other guys, they are also offering what we call dry cleaning service. And what is going to delight the customer? That's going to bring him back to mind. Just an SMS. Of course, SMS, can also be pretty tiring. Like I'm pretty sure, every time you make a transaction on perhaps internet, in your bank account, you probably get an SMS. Who cares? We get 17 SMS in a week. And we even forget what the transactions are about and so on and so forth. So those have become virtually, because they're automated, they've become a nuisance now. So one has to think really hard, what something that I offer, is it going to backfire for me? So what is the story in doing all these things? You got to make sure you understand the customer. You got to interact with him. You got to make sure you take care of what we call initially the functional requirements that would come from QFD, plain old QFD, that would take care of that. QFD will help you transfer, once you capture the voice of the customer, which are the different functional requirements that he requires, where the more is the better is the good way. How will you design the product and then the process and then the quality assurance system to make sure the customer eventually gets what he wants and he gets that high level of satisfaction with that. Then of course try to see if you could come back and offer the higher level of satisfaction, which is through the Carnot model. If you are able to locate any of those delighters, if you are able to do that, you are bound to win. There is really going to be not much of an issue if you've done all three steps. Something else you got to make sure is if you do spell out something to be a quality characteristic, please make sure it is measurable. And this is called CTQ, critical to quality. Some characteristic that you can measure, it becomes a CTQ, critical to quality. And of course, make sure there's a strong link between that and customer satisfaction. So at the end of your design, you should clearly spell out those characteristics that are critical to quality and make sure your process is designed to deliver them. Your quality assurance system is designed to measure them. If you've done that, It's only onward and upward for you and your business. We'll continue with our lecture. Thank you very, very much. Thank you.